Hey, here's a quick review video on measurement and geometry. So we reviewed some grades 6, 7, and 8 concepts on perimeter area, volume, and surface area. So just a quick recap, perimeter is the distance around an object. So add up all the sides of this rectangle and you'll figure out the perimeter. So this would be, you got a couple of 8s and you got a couple of 3s. Add them all up and you'll get 22 centimeters for the perimeter. Excuse me. And then a circle. So if you want to get the perimeter of a circle, we call it circumference, and we have a special formula for that, and it's 2 times pi times the radius. Or you can use the formula pi times diameter. They're the same formula because 2 times the radius is the same thing as the diameter. Okay, so let's figure out this one. So it would be pi times, well, it'd be 2 times pi, which we can use 3.14, times our radius is just halfway across the circle, so 3. And then we would multiply those. 2 times 3.14 times 3. And that would be the answer, which I don't have a calculator, sorry. And then for a triangle, for a perimeter, we just add up all the sides. We want to get the distance around the shape, so we would just add 3 plus 4 plus 5, which would be 12 centimeters. Area, we could find the areas of these 3 shapes above. So if you want to find the area of that rectangle, area of a rectangle is just length times width. So we would just do 8 times 3, which would be 24 centimeters squared, we would call it. Areas like if you had 1, 2, 3, 4, 5, 6, 7, you split that into 1 centimeter sections, and this will split into 1 centimeter sections. All together we would have 24 square centimeters on their shape there. And for the circle, if we wanted to find the area, we would use the formula pi times the radius squared. So 3.14 times 3 to the power of 2, 3.14 times 9. I don't know a calculator, so something. And then finally for the triangle, a triangle is like half a rectangle, so you're gonna almost use the area of a rectangle formula, but we're gonna call it base times height instead of length and width, and then we're gonna divide it by 2. So base and height always have to be at a 90-degree angle to each other. So it would be 3 times 4, and then we just divide it by 2. So 3 times 4 is 12, divided by 2 is 6 centimeters squared. And then we also talked about, we can change dimensions and see how that relates. So if we had a 3 by 3 square, well, the perimeter of a 3 by 3 square would be 3 plus 3 plus 3 plus 3. So 12 centimeters. The area of a 3 by 3 square would be 3 times 3, so 9 centimeters squared. Now if we doubled the dimensions of our square, so we're gonna have a square that is now a 6 centimeter by 6 centimeter, what would our new perimeter be? Well, it turns out our perimeter is also going to double. So 6 plus 6 plus 6 plus 6 is 24 centimeters. And that's the same thing as if we took the 12 and just doubled it. And then for our area, well, it turns out that the area actually quadruples. Because it's because you're multiplying it. So if you're doing length times width, and then you have double the length times double the width, well, these 2 2's, it's like now 2 times 2 is 4, length times width. So it's like it quadruples the area. So it's going to be an area of 36 centimeters squared. Okay. Then we also talked about volume. So I'm not going to go through all the volume formulas, but there is a formula sheet that you can use to find the volume of every shape. I'm just going to talk about the relationships between prisms and pyramids or cones. So it turns out that if you have a prism and a pyramid that have the same base, so say these have the same exact base, like the same length and width, and then let's say they actually have the exact same height, if all of that is the same, then pyramids are a third of the volume of a prism. So we usually say that the volume of prisms are the area of the base. So in this case, it would be just length times width times the height. That's how you can find the volume of a prism. The area of the base times the height. So if you had the identical shaped pyramid, the same height, the same length and width, it's going to have the exact same formula, area of base times the height, but it's only a third of the volume, so you're going to have to divide that by 3. And that's the same as cylinders and cones. So to find the volume of a cylinder, you would just do the area of the circle and then times it by the height. And to get the cone's volume, you would do the area of the circle times by the height divided by 3. So that's how the prisms and pyramids are related for volume. Then surface area, we had one of these on the test where you just had to find the surface area. Surface area is not that bad, it's just kind of annoying. Surface area is just where you would take each side and you would just find the area. So like this bottom shape, to find the area of it, you'd have to do base times length. It's such a big rectangle. And then you might also want to find the surface area of this, the front of the tent and the back. So to do that, it's a triangle, so you'd have to do base times height divided by 2. And you have 2 of those, base times height divided by 2. And then you have a couple more sides to add in as well. So you have this front side here, as well as the back side there that you would have to do length times width. So in this case, it'd be like C times L, and for the back one, it would be A times L. So surface areas would just find the area of each side of your 3-dimensional shape. Okay, we also talked about Pythagorean theorem, and that's where you have a right angle triangle, so a 90-degree triangle. This side is always the hypotenuse. It's always the longest side. It's across from the 90-degree angle. And it's always the longest, always. And you can find the length of that longest side by determining the square of each of the shorter sides. So it's like you turn these guys into little squares on each side. And it's like you're finding the area of them. So this is like doing 12 times 12 to find the area, and this is like doing 5 times 5 to find the area. So it's 144, this is 25. And then you can add those 2 short sides together. And they will actually give you the area of the square that's on the hypotenuse. So 144 plus 25 would be 169. And then to find the actual length of the hypotenuse, you would just square root 169, which would be 13. I can write this like algebraically too by saying a squared plus b squared equals c squared. So it's just where I take each side, so 12 squared plus 5 squared is equal to my hypotenuse squared. So 144 plus 25, add those together, and finally square root them to find the length of C. Sometimes you have to do a different thing where you already know the hypotenuse and you're trying to find one of the shorter sides. So in that case, the only thing that changes is now, since this is the biggest side, you'll be doing 10 squared minus 6 squared to get, let's call this side A. So you'll be subtracting because you know that actually it's these two sides that add up to the 10. So if you want to figure out one of the shorter ones, you have to subtract. So 10 squared would be 100, 6 squared would be 36, 100 minus 36 would be 64. And then finally we square root that. And we figure out that this side's actually 8 centimeters long. So that's Pythagorean theorem. We also talked about a number of geometry concepts. One of them is parallel lines. Another thing that comes along with parallel lines is opposite angles. So like if you have two lines that intersect each other, the angles opposite will always be the same. So that means this would also be 115. Then we also learned that if you have a straight line and you section it off into two sections, these two sections have to add up to 180 degrees. So that means this little guy in here is going to be 180 minus 115, which will be 65. And then we know this is 65 because of the opposite angle thing. And now using our parallel lines thing, there's lots of things we can figure out. We know alternate angles, so these two are the same. So this angle has to be 65. And then using the same alternate angles, we know that this one and this one would have to be the same. So that would be 115. There's also the corresponding angles, which sometimes people call like an F pattern. So like this one and this one are corresponding angles. So this would be 65 and this would be 115. We also talked about interior angles of shapes. So we know that the interior angles of triangles always adds to 180. And you can actually use that knowledge to figure out any other shape. So if you had a four-sided shape, well, it can be split into two triangles. So two triangles, 180 plus 180. So that means this guy would actually add to 360. That means if you knew three of the angles, you could find the missing one because you know it has to add to 360. Now, if you had a five-sided figure and you wanted to know what it added up to, well, I know that I could actually split this into three triangles. So 180 times 3 would be 540. So I know this has to add up to 540. And then we figured out that really, however many sides you have, you just take the number of sides of your shape and subtract 2. So for example, a five-sided shape here. So if I have 5 sides and I subtract 2, that gives me 3. And then I just take that number and multiply it by 180 because that's the number of triangles that can fit inside my shape. And that will tell me my shape can add to 540. So if I had like a 10-sided shape, I know I could actually fit 8 triangles in it. So I would just do 8 times 180 to figure out what the interior angles would add up to. Okay, and then we just solved some problems with it. So like for example, this one here, if I wanted to solve this, well, I know this triangle right here, I know has to add to 180. So if I just did 180 minus 42 minus 100, I would get 38 degrees. I also know that opposite angles are equal, so I know that this one would have to be 42. And then I know this triangle over here would add to 180, so I can do 180 minus 42 minus 88 and get 50. And that's how I can solve that one. We also learned a ton of circle properties, which honestly, I'm not gonna go through them all, but just an example one. here's where a triangle goes through the center of your triangle and then connects to one of the sides, or sorry, one spot along the circumference. And if that happens, if you draw a triangle in a circle and it goes through the center and attaches to a side, this angle will always be a 90-degree angle. And then you know triangles add to 180, so this is a common question where I could tell you this angle is 38. And if you wanted to find that, you know you just do 180 minus 90 minus 38. And then there's a few other triangle properties, one where like an angle is doubled, one where an angle is the same. So feel free to review those if you forget. And that's it.